One, let's start the question. So the question says that in a carnot cycle involving ideal non-linear triatomic gas, if during adiabatic expansion of volume increases from 2 liter to 16 liter and heat absorbed during isothermal expansion is 8 kilocalorie, then calculate magnitude of work done by carnot engine. So generally it is given that the non-linear triatomic gas, ideal non-linear triatomic gas, and during the adiabatic expansion the volume increased from 2 liter to 16 liter, and during isothermal expansion the heat absorbed is 8 kilocalorie. So now you have to find out the work done by the Carnot engine. So let's solve this question. So first we have volume V1 that is 2 liter, volume V2 that is 16 liter. So this is given, and non-linear triatomic gas is also given, and we have that during isothermal expansion heat absorbed is 8 kilocalorie. That means heat absorbed, that is Q. So Q is 8 kilocalorie. 8 kilocalorie. Now we know that the formula of efficiency, it is efficiency. We can write it as efficiency. So efficiency is work done divided by Q, that is heat absorbed, and here W is work done. And also we know that another formula is 1 minus T2 by T1. So this is another formula. So T2 is for sink and T1 is for source. So now we know that like PV to the power gamma equals to constant, Here we know that for adiabatic expansion PV gamma to the power equals to constant for adiabatic expansion or adiabatic process. So for adiabatic process we know that PV to the power gamma equals to constant. Here pressure is not mentioned. Here we have to deal with volume. So we take volume and temperature. So TV to the power gamma minus 1 for adiabatic process, TV to the power gamma equals to 1 equals to constant. Now we can put this formula to find out the T2 by T1. So T1 V1 to the power gamma minus 1 is equals to T2 V2 to the power gamma minus 1. Here it is given that non-linear triatomic gas. Non-linear triatomic gas. So for non-linear triatomic gas, gamma is 4 by 3. So now we can put it. T1 we don't know about T1. So T1 by T2 will be equal to V2 by V1 to the power gamma minus 1. And here V2 is 16 and V1 is 2. And gamma is 4 by 3 minus 1. So it will be equal to 8 to the power 1 by 3. So it equals to 1 by 3. So now it will be equal to 2. But we have to find out T2 by T1. So T1 by T2 is equals to 2. That means T2 by T1 will be equal to 1 by 2. Now we can put in the efficiency. So here 1 minus efficiency is W by Q and efficiency is also 1 minus T2 by T1. That means 1 by T2 by T1 will be equal to W by Q. So 1 minus T2 by T1 will be equal to 1 minus 1 by 2, that is equal to W, and Q is given as 8 kilocalorie. So it will be equal to 1 by 2 is equals to W by 8. So W, that is work done, will be equal to 8 by 2. It is 4 kilocalorie. So the final answer will be 4 kilocalorie. The magnitude of work done by the Carnot engine is 4 kilocalorie. So if we'll see the overall process, we know that first we have the heat absorbed, and we know that the formula of efficiency is W by Q as well as 1 minus T2 by T1. If you'll find out T2 by T1, then you can easily find out W because Q is given. So to find out the T2 by T1, we have to put the adiabatic process, that is T into V to the power gamma minus 1 is equals to constant. So for this formula, we can find out easily T2 by T1. Now putting the value of T2 by T1 in the part of efficiency part, we can easily find out the work done. So the work done is 4 kilocalorie. Hope you understand it well. Best of luck.